The audio is also clear, right?
Absolutely,
Yes,
sir.
sir.
Okay. So let me. Okay. So this screen is fine for me. Yeah. So let us start with another experiment, right? So just go to the classroom, and here I have uploaded experiment number 7. Okay. So I will just open it for your reference. Okay. So I'm opening it. So today we will see experiment number 7. The name of the experiment is verification of Kirchhoff's current law and Kirchhoff's voltage law. Okay. So as per the syllabus, these concepts will be covered in unit number 5. Okay. But as we are into the sequence, right, I will just tell you some basic concepts. Okay. And then we will learn these two laws, right? Theoretically, what is Kirchhoff's current law and what is Kirchhoff's voltage law. Okay. And once we will be thorough, or once we will clear the concepts of KCL and KVL, right, we will solve a small numerical on it. Okay. And then we will solve some numerical on it, and then we will see the value which are by using the simulation, right? So theoretical values we will be calculating for current, resist and voltage, and again we will calculate practically what is the values of currents and voltages, and then we will just compare, okay, whether the theoretical and practical values are matching or not. Okay. So that's the name of the experiment, verification, right? So we need to verify that whether these laws are applicable perfectly theoretically, and we are getting same reading as we are getting in theory in the practical also. Okay. Any problem in this?
No, sir.
No, sir.
No, sir.
Okay. So the aim is to verify this KCL and KVL. KCL is Kirchhoff's current law, and KVL is Kirchhoff's voltage law. Okay. So these are the components what we need for measurement of voltage. We need voltmeter. For measurement of current, we need ammeter, right? So both are present in what? Both are present in
Multimeter.
multimeter,
Multimeter.
right? Okay. So we will be using multimeter, and then we want a circuit board. So in our simulation software, what we will be using? A breadboard.
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 Okay. And then we want a power supply to give the power. Okay. So these are only 4 components we need. Okay. Now let me cover some theory part. Okay. So there was a German physicist, right? So his name was Gustav Kirchhoff. Okay. So he came up with 2 laws. One is your Kirchhoff's current law, and second is your Kirchhoff's voltage law. Okay. So let us deal with this. Now, let us say that there is a circuit. Okay. So some basic part I will be covering. So let us say that there is a small circuit. So in this circuit there is a resistor, right? And let us say that I am applying a battery to this. So battery is having 2 terminals, plus and minus V. Okay. And then due to application of this battery, क्या होगा? बैटरी को लगाने के बाद में क्या होगा? ये क्लोज लूप है. So what will happen due to application of this current
Yes,
will
sir.
flow, correct? Yes, no?
Yes, sir.
Okay. Now let us say that I am increasing the circuit. Okay. Will current flow in this R2? Will current flow in this
No.
resistor?
No, sir.
No. Why? ओपन सर्किट है. ओपन सर्किट में करंट फ्लो ही नहीं होता है. Will current flow through this
Yes.
R3? Yes. Okay.
Yes, sir.
Now
Yes, sir.
Yes,
if I
sir.
apply some another battery here, let me call it as V1, let me call it as V2. Will current flow in this circuit? Let us say it is I2. Let us say this is I1.
Yes, sir.
Will current flow through R2? Yes. Will current
Yes,
flow
sir.
through R3?
Yes,
Yes.
sir.
Okay. Now, see here. See, let us suppose that if I am not applying this battery, okay, then current will not flow. Okay. If I make it as a short circuit, will current flow through this R2? जो
Yes,
यहाँ
sir.
से आने वाला current है, it will get divided into 2 parts. One current will
Yes,
flow
sir.
in this loop, another current is flowing through R2. Correct? Yes, no?
Yes, sir.
Yes, sir.
Okay. Means
Yes,
can I
sir.
say at this point, can I say current is getting
Current is
divided?
distributed. Yes, sir.
right?
sir.
Yes, sir.
So this point is called as node, right? This point is called as node. Okay, so you can say that whenever there are three or more branches connected together, at that point current will get divided. Okay, at this point current is same, right? Because whatever current is flowing here, current will be going here, right? So can I say the incoming current towards this node with respect to this node is equal to the current which is going out of this node?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
this is node B. So node, देखिए node पे करंट रुकेगा क्या? नहीं,
No, sir.
right? This is also node, right? So node पे करंट रुकेगा क्या? नहीं.
No, sir.
Let us suppose यहाँ से 10 amperes of current आ रहा है, तो यहाँ पर अगर 7 amperes जा रहा है, तो यहाँ पर कितना जाएगा? 3 amperes. But there will be no current which will stay on the node, correct?
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
Now let us consider this as a node, and let us consider, okay, just, and let us say that there are few currents. I will name it as I1. Let us say this is I2. Let us say this is I3. Let us say this is I4, and let us say this is I5. All right. Okay. So how many currents are there? 5 currents. Okay. So what I told that at any node current will not stay, right? मतलब क्या,
Yes,
जितना
sir.
करंट नोड पे आ रहा है उतना पूरा चले जाएगा, right?
Yes,
So
sir.
can I just in simple words ऐसे लिख सकता हूँ, incoming currents is
Equal
equal
to
to
outgoing current.
outgoing current, right? So what are incoming currents? Incoming
I,
means what? Towards the node. हाँ बोलिए. So it will be
I1 plus
I1,
I4.
I1, I4, I5.
very good, I4 plus
I5.
I5 is equal to outgoing. Outgoing मतलब कितना है?
I2
I2
plus
plus I3.
I2 है और
plus I3.
I3 है, correct? Now let us suppose I am writing the equation like this. Arithmetically I am writing, okay? I am just taking I2 and I3 in the left hand side, so it will become minus, correct? Correct? Yes, no?
Yes, sir.
Okay.
Yes.
So I am treating, in this equation I am treating incoming current as positive, and outgoing current as negative, correct?
Yes, sir.
Yes, no? Incoming currents पूरे
Yes.
positive है, outgoing. Now see why I am talking about this positive and negative, because if you will not means get proper with the direction, then at the end what will happen? Your total, अगर एक भी direction गलत होता है तो फिर क्या होगा? Your total analysis of the circuit will go wrong. Yes?
Yes, sir.
Yes, sir.
Okay. Now see here. Can I say ये addition है, right? So this is your summation. Okay, so summation of current is equal to 0, right?
Yes, sir.
Okay, but this, which is this summation? It is algebraic summation, because we are considering the positive signs all as well as negative signs. So Kirchhoff's current law क्या बोलता है? The algebraic summation of the current at any node is equal to 0. Algebraic summation at any node of the circuit, right, of all the currents is always equal to 0. समझ में आया?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
So very good. So this is your, what we can say, this is Kirchhoff's KCL. क्या बोलेंगे इसको? Kirchhoff's current law. Any problem in this?
No, sir.
No, sir.
Okay, okay. Now see, very carefully you just note all the notes, because all these calculations you have to uh, uh, put in your lab manual, right? So I will get with a fresh page, and then I will start with Kirchhoff's voltage law. Okay, so what is voltage law? We have already experienced this voltage law in couple of circuits which I have told to you, right?
Yes, sir.
For example, let us say again same circuit I am taking R1, R2 and R3, right? And then I am applying here some voltage, let us call it as V1. Let us say that this voltage is nothing but V2, okay? And let us say that this direction of the current is I1, and let us say I1 is a current which is flowing in loop number 1, okay? Let us say this is your second current, let us say this is I2. I2 is a current which is flowing in loop number 2. Any problem in this?
No, sir.
No, sir. No, sir.
No, sir.
Okay,
No,
okay,
sir.
okay. Now very important, right? आप लिख भी सकते हो that the components which are common to the loop, with the components which is common to the two loops, in that two currents will flow, right? So यहाँ पर कौन सा ऐसा component है जो दो loop में common है?
R3.
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 So R3 में कौन से component flow हो रहा है? I1 भी
I1
flow हो
और
रहा है,
I2.
And I2.
I2 भी flow हो रहा है, right? Both are in the same
Yes, sir.
direction.
Yes, sir.
Yes.
So
Yes.
so current through R3, current
I1
through
plus I2.
R3, let us call it as I3, and I3 is
I1
equal
plus
to I1 plus,
I1 plus
I1 plus I2.
I2.
correct? Now this is a you can say private component in loop number 1. So let us say I1 is flowing through this. From here I2 is flowing. These are all the currents which I am assuming the direction of the currents. Okay? Yes, no?
Yes, sir.
Okay. Now can I apply here KCL? So can I say this is KCL is applied here, and I'm getting the equation by using KCL? Yes, no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So what is I3? I3 हम लिख के रख देते हैं साथ में, right? What is I3? Current in R3. Yes, no?
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay. So let me just overwrite it with blue color. Okay. Now what Kirchhoff's voltage law say? Kirchhoff's voltage law is based on, yes, Newton's law. Energy can neither be created nor be destroyed, right? It can
Yes,
be
sir.
transferred from one form to another form, right? So similarly here, what is the source which is giving the energy? Voltage source, right? So this total applied voltage is equal to the voltage which is consumed by the resistor, correct? Yes, no?
Yes, sir.
Means
Yes, sir.
इसका मतलब ये है कि जो voltage V1 है, that is equal to some voltage drop across R1. So let me call it as some voltage drop across R1. So VR1, and some voltage drop across plus minus VR3, right? Okay.
Yes, sir.
Now,
Yes, sir.
what I will do, I will apply KVL in loop number 1. Okay. So loop number 1 means what? I will consider only first loop. Okay. So what is the first loop? Again, I will redraw the circuit. Here. Okay. Let us call it as V1. This as I1, and this as R3. Correct. And then what I will do, I will just assume the current direction as I have assumed in the original circuit, right? So what is your I1? What is your okay? What is the direction of I1? What is current in I1? R1, I1.
I1.
What is current in R3?
I1 plus
I1 plus
R,
I2.
I2.
Getting, if we are considering the current in second loop also. Yes, no? Okay.
Yes, sir.
So by KCL, I can write from this. This is only for your explanation, right? So I will just write what is the total current. See, direction also, whenever I am traveling from plus to minus, I will assume the direction as minus. And whenever I am traveling from minus to plus, I will assume the direction as plus, right? Okay.
Yes,
So
sir.
let us start from here and we will end here. Okay. So यहाँ से मैं ऊपर जा रहा हूँ. So from minus to plus, what I will write?
Plus R1
V1,
plus.
right? Then plus minus. I will just assume the direction of voltage drop. Assume कैसे करेंगे? Current जिस टर्मिनल को पहले हिट कर रहा है, that I will assume it as plus, and जिस टर्मिनल से लीव हो रहा है ना, वहां पर माइनस. ये सिर्फ किसके लिए? रेजिस्टर के लिए लिख रहा हूं मैं. ओके. सो बोलिए प्लस टू माइनस, प्लस या माइनस?
minus,
प्लस टू माइनस.
Minus.
Minus.
What is voltage drop across R1?
I1 R1.
हाँ, I1 into R1.
R1.
Okay. Again, plus to minus. What is the current flowing in this R3?
I1
I1
plus
plus
R2 into R3.
I1 plus
I2
I1.
into R3 is equal to 0, right? So I'm writing this equation. See here, -2 plus V1 plus 2 minus VR1, voltage drop across R1, I1 into R1 plus 2 minus VR3, what is voltage drop across R3? So current through R3 is I3 is what? I1 plus I2 into R3, correct? So therefore I can write it as V1 is equal to I1 R1 plus I1 in plus I2 into R3, correct? Yes, no?
Yes, sir.
Yes,
Yes,
sir.
yes.
So this is equation number 2. Am I correct?
Yes, sir.
बराबर है? Simple
Yes,
है?
sir.
Okay.
Yes, sir.
Okay, good. Now let us, can I write from here second equation? Okay. So let me just, so from here I can write a second equation, right? I will just put a line here. Okay. So second equation, how I can write? Second equation, how I can write? बोलिए.
V2
So
minus
चलो,
I2 R.
यहाँ से
V2
कहाँ चालू
minus
करते हैं? यहाँ
I2
से,
R2.
यहाँ से देखिए, यहाँ से चालू करते हैं. यहाँ से इस डायरेक्शन में करंट को अज्यूम किया है ना, तो बोलिए -2 प्लस
plus
V2
Plus V2
प्लस 2
minus
minus
I2 R2.
minus I2 R2
Yes, sir.
R2 plus 2 minus what is
minus
I1
I1 plus an I2 into R3
is equal to
Zero.
0.
0.
So can I say total applied voltage V2 is nothing but some voltage that will get drop across R2 plus some voltage that will get drop across R3.
R3.
Yes, no. So this is equation number 2.
2.
Yes, no.
Yes, sir.
Okay.
Yes.
Okay. Now let me now let us say that we will solve a problem on this. Okay. Now what we need to do, we need to find voltage across R1, voltage across R2, voltage across R3, current I1, current I2. इतना सारा आपको find out करना है. What is given? Given is, I will just write in red color. Let us say this is 10 volts. Let us R1 say, let us say it is 5 kilo ohms. R2, let us say it is 10 kilo ohms. And let us say this is 20 volts. And let us say this is 15 kilo ohms. Is it okay? Yes. So what I have considered, R1 is equal to 5 kilo ohms. This is given data, right? R2 is equal to 10 kilo ohms and R3 is equal to 15 kilo, right? And what is V1? V1 is equal to 10 volts and V2 is equal to 20 volts, right? So this is the given data. Any problem in this?
No, sir.
No, sir.
Yes.
No, sir.
Okay. Okay. So just a second. Okay. Just a second. आपका भी कुछ है क्या? तो बोर्ड लगेगा क्या? Can you give me that space? आप वहाँ पर पर्सनली. Okay. Okay. So yes. So now can we find the equation by substituting these values? By substituting these values, right? So just substitute these values. V1 10 volts is equal to I1 नहीं पता, R1 5 kilo plus I1 नहीं पता, I1 plus I2 multiplied by R3. R3 is what? 15 kilo,
15.
right? And then I will just write properly. So this 10 is equal to 6 times I1 plus, not 6 times, 21 times, right?
Yes,
देखिए,
Yes, sir.
quadratic sorry,
21 times.
2 equation 2 unknown. So 15 I1 plus 5, 15 plus 5, 20 I1, right?
Yes.
And then this is plus 15 I2. This is equation number 1. Yes, no?
Yes, sir.
Yes,
Okay.
sir.
And then I will just write here V2 is nothing but 20 is equal to I2. I2 is what? Unknown. R2 is what? 10 plus
10.
I1 plus I2 multiplied by R3. R3 is what? 15. So 20 is equal to 10 I2 plus 15 I2. Let us say it will become 25 times I2 and this is 15 times I1. Is it correct? So this is equation number
2.
2. Correct? Yes, no?
Yes, sir.
Yes, sir.
Yes, no?
Yes,
Okay.
sir.
Now, these are two equations, two unknowns, right? So can you apply some method? You have the scientific calculators, it is allowed in the exam. So you can just use the scientific calculators and you can find the values, right? Quadratic equations. So you can just get the value of I1 and I2 by solving these two equations, right? So what is I1 and what is I2? What is I1? What is I2? I2? And what is I3? Right? Yes. Okay. So if you don't know, I can just find out the values, right? So okay, so these are the two equations, right? So I can just write it as, or you have the scientific calculators, right? So you can use the scientific calculators. Do you know how to use the scientific calculators? Yes, no?
No, sir.
Hello.
No, sir.
Huh?
No, sir.
No, sir.
So in that there is modes, right? So that is your equation mode. So here I can just solve these equations, right? Or simply you can just solve these equations. Okay. So how to solve these equations? Can anyone say me? Tell me. Solve and tell me the values of I1 and I2. Just tell me the values of I1 and I2. Yes. So yes, anyone came with the answer? Yes, what is I1? I2 and I3. And then let us calculate VR1
So I1 is 0.18.
and VR2, voltage across R2, and this I3 is I1 plus I2, and then VR3. Yes, so yes, I1 is how much?
2.18.
Huh?
0.18.
0.18
8. Yes, sir.
milliampere, right?
Yeah. No, ampere
Milliampere.
only.
मिली
Ampere.
क्योंकि ये किलो था ना,
हाँ सर, मिली एम्पियर.
तो ये मिली एम्पियर हो जाएगा.
हाँ सर, मिली एम्पियर.
Okay, what is I2?
0.9.
0.9
9.
milliampere, right? Okay.
Yes, sir.
And I1 plus I2 will be
1.08.
1.08.
0.27. 1.08.
0.08.
0.08
Yes, sir.
milliampere. And then this is I1 into R1, 18 milli into 5. So it will be, yes,
0.9.
0.9.
0.9 volts. I2
Yes,
into
sir.
2 means 0.9 into 10 kilo ohms.
10.
How much?
9.
9 volts. And then this is 1.08 into R3 is 15. So how much it is?
1.62.
Huh?
No, sir. 1 minute. 1.
Yes.
16.2.
Huh?
16.2.
16.
16.2.
Yes, sir.
Volts.
60.2 volts. Is it correct?
Yeah.
Yes, sir.
Yes, sir.
Okay. Now let us check. Okay. Let me solve this equation. So this is 10, 20, 15. So this is 20x plus 15y is equal to how much? 10. And second equation was 20, 15, 25, 15, 25, 20, 15, 25, 15, 25 equal to 20. Is it correct? And I will
Yes,
just
sir.
calculate. So what is x value and what is y value? So just 1 second. So this is just a second, okay? Uh, 20, 15, 10.
So it's
15.
right. Even I got negative.
Huh?
Even I got negative value. So X.
You got negative value?
Yeah,
Yes,
sir.
sir. I have
The
also got
It's
that.
total.
because direction, sir. We did
Yeah.
not take
The
direction.
direction.
So it is 10 by 11. How much is 10 by 11?
That is 0.9 only.
0.9.
0.9.
Okay. And what is
0.999.
2 by 11?
0.18.
0.18.
Okay.
0.18.
So what is the thing? I have just confirmed and this is your negative. So this will also be negative. इसका मतलब ये है कि whatever current direction we have assumed that was
The opposite.
opposite, right? Okay. So let us build a circuit and let us verify this circuit, right? So for that I will just build a circuit on Tinkercad, tinkercad.com, and then I will go on circuits and I will create a new circuit, right? Okay. And then what I want a breadboard. Okay. I want some basic components only. So I want a breadboard and see, and then I want resistors, right? Resistors. So this is one resistor. This is another resistor. Third resistor. This was how much? This is, yes,
5 kilo ohm.
5, 10 and 15. This is 5. इसका नाम क्या था आपका? R1.
R1.
This is R2. This is 10 and this is R3. This is 15, correct? And then I need a power supply. Power supply. One at this side, one at this side, right? So I'm giving a power supply such that positive is connected here to resistor. Yes, no? Yes or no?
Yes, sir.
Yes.
Okay.
Yes.
Yes, sir.
And negative is connected here to this resistor. Okay. I will just denote it by black color. Okay. Now, if I want to measure I1, what I will do? I need a ammeter,
Multimeter there.
multimeter. So multimeter I will take. I will just put it here. And then what happens, from this wire will go here and from this. Okay. So let me, right? And from this wire will go here. Let me put it as black. Okay, any problem in this? And this is to read your amperage. Okay, any problem in this? Yes, no?
No, sir.
No, sir.
This is your I1.
No, sir.
Okay, and then similarly, this is connected here, this is connected here, and whatever current will flow through this. Okay, what I will do, I will just connect it here. Okay, and then what I want this is your let us say that another power supply, and through this again I want to measure current. So let us configure it to measure current. So from this it will go here, and from this it will go here, right? Okay, so this one same colors I will be using. Okay, getting what I am doing? And this I am connecting it here. Any problem in this? Yes, no?
sir.
Okay. Okay. And then I want one more ammeter, which will be okay. One more ammeter, which will measure I3. So I3 के लिए मैं यहाँ पर रख दूँ. Okay. So from this point, it will go to this here. Okay. And from here, the current will flow to this resistor. Any problem in this? समझ में आ रहा है?
Yes, sir.
Okay, and this is again for measuring this amperage, and this is your I3. Okay. Yes. Okay.
Yes.
Okay. And what is remaining? This I will be giving it to here. Okay. Now, how much is this voltage? How much is this voltage? 10 volts and 20 volts, right? So I'll just configure it as 10 volts. And this is 20 volts, correct? Yes, no?
Yes,
Yes, sir.
Let me run the simulation. Okay. So, correct hai? Yes, no? So, suniye, just 1 second, okay? So, 0.18, is it correct? Minus 0.18 milli means what? 182 micro, is it correct?
Micro.
Yes, sir.
Okay. This is 0.9 milli means what? 909 micro, is it correct?
909. Yeah, correct.
Yes.
Yeah. And here this is minus
Sir.
I1 plus I2. So, therefore, this will be
0.72. 0.72. Yes, plus 72 something.
0.7 milli. 72 milli. So if we just go here and if we see, is it correct? 0.72 microampere? Yes, no?
Yes,
sir.
Yes.
Perfect.
Perfect.
Okay, good. So you can just see this right up, and then here is a Kirchhoff's current. Here you can just see I1, I2, and I3 theoretical values as well as practical values. Yes. Can you note
Yes,
down
sir.
the theoretical and practical?
Yeah, sir.
Okay, okay. Now let us see voltages. Okay. So now if we want to measure the voltage, what I will do? See, again I will use a voltmeter. So let us suppose at downside I am using as a voltmeter. Let us say this is VR1. Okay. And this we will just across this terminal we will measure the voltage. I will use this color here, purple, and maybe some another color. Maybe I will get some gray. Okay. So this is your voltage measurement, VR1. Similarly, for VR2, I can get this voltage like this. So negative is connected here, positive is connected here, right? And let us say that this is measuring voltage across R2, correct? And similarly, I will measure voltage across R3.
Yes,
Okay.
sir.
So just I will just rotate for your reference. Okay. Rotate नहीं करता हूँ, सीधा यहाँ से connect कर दूँगा, right? So positive I will just connect it here. Okay. ओके सो थोड़ा सा यहाँ से लॉन्ग कट लेते हैं, यहाँ पर लगा देंगे राइट, एंड नेगेटिव वी विल कनेक्ट इट टू this point. Is it okay whatever I am doing?
Yes, sir.
Yes,
Yes.
sir.
And whatever voltage I am getting, I will just call it as VR3, right? Okay, now let me run the simulation. Wow. So see, 909 millivolt means what? 9 volt voltage across R1, 0.9 volt, correct? Yes, no?
Yes, sir.
Okay. And then
Yes, sir.
this is how much? 9 volt again. VR2 is 9 volt. Am I getting 9.09? Yes, no?
Yes,
Yes,
sir.
sir.
Okay, very good. And then again, what I am getting, VR3 will be 0.72 into this thing, right? So it must be 10.9 volts. Okay.
Yes, sir.
Yes, sir.
Yes, sir.
So can you just see what are theoretical and practical values? Okay, you just neglect these things. Yes.
Yes, sir.
Yes, sir.
So can
Yes,
I say
sir.
that here we have verified the Kirchhoff's current law by seeing that this I1 plus I2 is equal to I3, as well as we have seen the voltage law also, Kirchhoff's voltage law. Yes, no?
Yes.
Yes, sir.
Yes, sir.
Okay. Any difficulty in this?
No, sir.
So can you perform the practical? Can you?
Yes,
Show that
sir.
circuit once more, sir.
Yes. Okay. So I will just stop recording, and then if any difficulties, I am here. You can just ping me.